All right, we are throwing section 2.6 into the chapter 1 content, and it will be included in the chapter 1 test. So only the 2.6 or 2-6 proving angles congruent is all we're going to cover in chapter 2. And this is the first time that we have what's called a theorem. Theorem 2-1 is the vertical angles theorem, and a theorem is a conjecture or a statement that we can prove to be true. And proofs must always be proven true, and they're either proven true in the examples of the book, or sometimes they're saved as problems in the exercises. But the point is that proofs are, or theorems are proved to be true, and then we can use them in further geometry concepts. So the vertical angles theorem states that if we have vertical angles, and remember vertical angles are angles that are formed by two intersecting lines, so angles 1 and 3 are vertical angles, and 2 and 4 are vertical angles, and this theorem simply states that when we have vertical angles, that vertical angles are congruent. Vertical angles are congruent, therefore their measures are equal. If you'd like to view the proof of this, it is on page 121 of your book. So let's look at an example of how we can use the vertical angles theorem. In this example, we have vertical angles formed by two intersecting lines. So these two angles here are vertical angles. And because the theorem says that vertical angles are congruent, we can solve this by setting these two angle measurements equal to each other. Therefore, we could say that 2x plus 21 is going to be equal to 4x. Go through the algebra steps, we can subtract 2x from both sides, and we get 21 is equal to 2x. Dividing both sides by 2, and we get that x is going to be equal to, in this case, 10.5. We could look at another example. In this example, if we look at these two lines here, these are intersecting lines, and so we have vertical angles, this angle, and then the combination of these two angles are vertical. So we have this angle and the combination of these are vertical angles. So in this case, our algebra would be 3x is going to be equal to the 40 plus 2x, 40 degrees plus 2x, or we could say 2x plus 40. Solving the algebra, we would get that x is equal to 40 degrees. All right, there are a couple other theorems in this section as well. Theorem 2-2 is called the congruent supplements theorem. And the congruent supplements theorem just says that if you have two angles, angles 1 and 3 are supplementary angles, and angles 2 and 3 are supplementary angles, then angle 1 and angle 2 must be the same measurement, or they must be congruent. So again, if two angles are supplement to the same angle, then the two angles are congruent. Likewise, we have a couple other theorems. We have the congruent complement theorem. Congruent complements theorem says that if two angles are complements of the same angle, then the two angles are congruent. Remember, complements mean that they would add up to 90 degrees. So if angle 1 and 2 add up to 90 degrees, and angles 3 and 2 add up to 90 degrees, therefore 1 and 3 must be congruent. Then we have theorem 2-4. 2-4 just simply says that all right angles are congruent. And basically, since all right angles equal 90 degrees, therefore they must be congruent because they have the same measures. That's a pretty simple theorem. And then theorem 2-5. Theorem 2-5 says if two angles are congruent and they are also supplementary, then they must be right angles or they must be equal to 90 degrees. So if we think about that, if two angles are congruent, Okay, that means they have to have the same measurement, and they're also supplementary. Supplementary member adds up to 180, so that would mean that they would have to both be 90 degrees. So again, these theorems are all in your book, and they are either proven in the book, or as you can see, some of them are left up as exercises to be proven, but these are all pretty basic theorems. So now we can look at another example of where this might come into play. So this question says, what are three equations that could be used to determine the value of x in the figure below? So if we look at this figure below, we do have lines intersecting. So we have vertical angles 8x minus 12 and 7x plus 8 are vertical angles. We also have linear pairs. If we look at these two angles right here, remember we can assume 180 degrees, so those are going to add up to 180 degrees, and these are going to add up to 180 degrees. So the three different equations that we can come up with, equations based on the vertical angles. 8x minus 12 is equal to 7x plus 8. Or we can come up with equations based on the linear pairs. 8x minus 12 plus 32, 8x minus 12 plus 32 is equal to 180. And then this linear pair down here, 7x plus 32 is equal to 180 degrees. So notice there are three different methods in this case on how to solve for x. Your job then would be simply to pick any one of the three equations, and then use that to solve x. It is a good idea to maybe choose two of them, and then when you solve for x, if you get the same answer, then that's a nice check, and you know you've done it correctly. Okay, so now for your homework continued, is this time instead of doing the online questions, I'm going to have you do a couple of problems, work a couple of problems, and then bring those in for points. The first problem is to go ahead and solve that last example that we did, remembering that you really only have to solve one of the three equations. A good idea would be to solve two of them to see if you get the same answer or not, or perhaps even all three of the equations. The second problem, solve this equation for x and y. So when you're done, you need to find what x is going to be equal to and what y is going to be equal to. Okay, so those two problems, work those two problems on a separate sheet of paper and bring those in, and they will be turned in. Thank you.